Okay, so what we are doing now is I will do a small demo of NGAC that will show up some of the building blocks that we have seen during the entire day, right? So early in the morning, we saw a session about workload identity, machine identity, where those identities are important beyond user login, right? This demo will cover a scenario where we are configuring access control for service-to-service access, and we will be leveraging these workload identities and machine identities that are implemented with Istio and SPIFFE. We have also seen some talks a lot about service mesh, Envoy, and how that builds this security kernel. So you have these distributed policy enforcement points, which are the Envoy sidecars. We will be using that in this demo to do the enforcement point for all the traffic that comes and goes from these applications. And of course, NGAC, right? So in this demo, NGAC will be the actual PEP, and we have several applications running in a Kubernetes cluster that we will protect using NGAC access policies, right? So big part of the demo will be showing some NGAC APIs that you can use to configure this to access to this application. So you can see here a development application that has a front end, set of backends, and a database layer, typical 3-tier application, right? But there's something weird here. As we can see, this development front end, this is accessing a production backend as well as a development backend, right? That doesn't look like correct. So we will see how we can use NGAC policies to prevent this access from development to production, for example. We have another production application that is pretty much the same, 3-tier application, some front-end, back-ends, and databases. And we can see that this production front-end is accessing directly services in the production database layer. That it's not okay, right? So the database layer should be only accessed from the backends. So we will see again how we can use these NGAC policies to configure access control for that and more stuff, right? One of the things that I want to highlight is that these policies, the objective is we'll be using all these kind of workload identities and low-level identities, machine identities, but we will be authoring policies in a high-level way, right? First of all, let me show you the NGAC components that are deployed in this cluster. As we saw in the question before, so these are the main 3 NGAC components that we have deployed here. Hopefully this is readable. We have the NGAC PEP. That's the one that will intercept all the requests. All the Envoy sidecars in this service mesh will be sending requests to this NGAC PEP to just allow or reject those requests that are coming and going from the sidecars. This NGAC PEP will be talking to the NGAC PDP, the policy decision point that is represented with this NGAC. This NGAC service is the one that has the PDP. This is holding the graph. It's implementing the NGAC traversal algorithm to make the access decisions. And finally, we have this NGAC controller, which is the one that is keeping the NGAC graph up to date, right? So NGAC policies are based on traversing the graph to make access decisions, and this NGAC controller will be watching the state of this Kubernetes cluster, what services are in it, what pods are running, what service accounts exist, what namespaces are there, what nodes, and we'll be pushing all this information to the NGAC graph for further policy evaluation. So this is an example of a possible representation of a Kubernetes cluster where we have the namespaces, the deployments, the pods, we have services, the nodes. So this NGAC controller is basically keeping this up to date so that we can create policies that use that graph and the relationships between the different elements to configure how policies cascade. Right. So now we will try to fix this development application and prevent development from talking to production. So we'll configure a policy that will split the 2 environments, right? In NGAC, we have seen that you can create multiple types of policies and combine them in a single access decision. So we will see a set of APIs that allow you to do that. The first API that we're talking about is this policy class thing that you see here. Hopefully it's big enough to be readable. So we are creating a policy class that's a type of policy, right? It's not one particular policy, but a type of policy that we will use to model the different environments that exist in the organization, right? We are calling this policy class environment, and we will use it to model what is production, what is development, what is staging, right? so that then we can write access policies using these nouns. I want to write access policies in a high-level way using production control to production, development control to production, instead of individual identities. Once we have the policy class, we can create attributes on that policy class. And in this example, we are creating an attribute that configures what is production. We have this prod attribute that belongs to the environment policy class. And this attribute is configuring the resources that will be part of production. All the resources declared in here will inherit and get the prod attribute. So all the resources in the front-end namespace in the kind cluster will get the prod attribute. All the resources in the backend namespace and in the databases namespace, again, will get this attribute, right? This syntax that you see here, this /*, just express the cascading, right? Not only this front-end namespace, but everything within it, right? All these objects will get the production attribute so that we can write access policies based on that attribute. The same way that we can create attributes to kind of group resources, the resources that we want to protect, we can also create attributes to group the authenticated principals that interact with the system, right? So we are creating here a plot clients attribute in the environment policy class again, and we use this subject element to express that we are grouping now users or authenticated principals interacting with the system. So here in the prod clients attribute, we are capturing all the service accounts in the front namespace, all the service accounts in the backend namespaces, and all the service accounts in the databases namespaces in the kube cluster. Once we have these attributes, these policy classes, we can create the actual access control policies that will configure what permissions do the authenticated principals have on their resources. In this example access policy, we are creating a prod access. We will configure who can access any object that has the prod attribute, right? So any object that has the prod attribute will be protected by this policy class. Right? And next to it, we are configuring who can access that, to whom we are granting access, right? Access is granted to this set of sources. The first one is another attribute. So any object with the prod clients attribute, which is the list of subjects, the service accounts that we have defined before, in the attribute before, will be able to access any resource that is part of the prod attribute. And also we can not only talk about groupings, but we can also do fine-grained access. Here we are whitelisting one very specific SPIFFE identity. This is the workload identity of a workload. This is the ingress gateway that we have in the environment. That's the URL that we are typing up here that is just forwarding traffic inside the cluster, right? So we are allowing only that ingress gateway as well to access the production environment. So we'll see if we apply these policies in the cluster, what is the effect that basically configures this who can access the prod services. So we create the policies and we can see now that we have several policy classes in the cluster. We can see a default one, which is the basic policy. If there's no policy, what happens? That's the default one that I created before. And we can see our environment policy class created as well. We can also see the attributes that we have defined. We have now the prod configuring the production resources and the prod clients, the users that can interact with production resources. And we can see the access policy that we just created, that is the prod access policy that configures who can access production. So now, if we go back to the development application and refresh the page, we will be able to see how the access now is denied because the identity that is used by the development frontend is not part of these subjects in here that are only the ones allowed to talk to production. Right? So if we refresh the page, we see this is in red now because the request that the development frontend is making to the production backend is failing with a 403 with a forbidden because of this production policy. If we go to the production application, we will see that nothing changes in the production application because all the services in production can talk to production according to the policy that we have just created. We can refresh and we can see here everything is still in white because there are no errors. Right? So the next thing that we want to fix is how we can, for example, model another policy to prevent this direct access from the front end to the databases layer, right? And we don't want to have a specific policy just for production, for the front end to the databases, but we want to conceptualize the notion of a three-tier application, right? What is the front end layer, what is the back end layer, and what is the databases layer? And create policies saying front end can talk to back end can talk to databases, no matter what are the identities. I don't want to be updating every single time I deploy a new service, adding an identity to the access control list. I just want my policies to be stable and reason about them, even though they are enforcing the identities. So we can create a three-tier app policy class to model this, and we can create the attributes that describe the different layers, like the prod front end that will capture everything in the front end namespaces. We can create the prod backend that will capture everything in the backend namespaces. And we can again create this kind of prod databases attribute that will capture everything that is running in the databases layer. So now we have attributes to qualify all these layers of a three-tier application. And we can start writing access policies based on those attributes, right? So I can create a policy that is front-end access and configure who can access the front-end layer. In this example, the only one allowed to access the front-end layer is the ingress gateway. No one else will be able to do requests to that front-end layer. We can create another access policy configuring who can access the back-end layer. And we can say all the services that are part of the front-end namespace can access the backends, but no one else. And similarly, we can create a policy to configure who can access the databases layer, saying that only the services in the backend can access the databases, right? So this way of expressing policy, you are targeting attributes, but the policy at runtime will be based on the SPIFFE identities. This is just attributes that will end up cascading, and policy will be inherited by those identities. So access control, the PEP, will do a request like, can this SPIFFE identity access that resource? But the policies will cascade, right? So if we apply these policies now, and we refresh the production page, we will see that now the direct access from the front end to the databases layer is no longer allowed, and it's returning a 403, right? And we have just written a policy that is in the terms of backend can talk to databases, front end can talk to backend, right? And this is a policy that we can very easily reason about instead of seeing individual low-level identities. Another thing that we can do is, for example, let's imagine that this database in here that we have here in production in the backend has sensitive data. And we want to configure that sensitive data can only access from specific places, right? For example, sensitive data can only be accessed from the backend in the US because I want to be just only local regional access to be allowed to this data, right, to this database. So how could configure with that in NGC? We could create, for example, again, a sensitivity policy class to start qualifying and grouping what we consider that is holding sensitive data. And we could create an attribute that is called just sensitive data that tells us what we consider to be that, right? In this case, this is just the services in the database layer, just for easy, but we will demonstrate a bit later, data policies as well. And we could introduce concepts like location and other stuff as the sources of who can access this sensitive data. So we can see here that we have a regional access policies that is configured who can access anything that has this sensitive data attribute. And the sources is, as you can see here, is region //. This will configure anything within this region can access this, any resource that has the sensitive data attribute, right? So if we apply this now, we will see how this policy combines with the others. And when we refresh the page, this backend EU will no longer be able to talk to the database. And we see that this is now failing and it's in red, and that's returning a 403, right? And this is these three policies combined together, right? One is the data sensitivity based, the other one is the environment based, the other one is the three-tier application policy. All of them are combined together in a single access decision in a very nice way, right? And when it comes to reason about the system, what policies do you have? You have these three policies that says who can talk to sensitive data, this is what you reason about, As long as the resource is captured by the patterns that you put in there, you don't have to change the policy all the time. Same with prod, same with in 3-tier application. You deploy a new service in production, the production policy class will already cover it. You don't need to be updating it all the time. Right? So this syntax opens up the door to do a lot of different policies, right? For example, we could imagine having a compute-based access policy where you can model who can talk to resources that I have in the cloud, right? I have a bunch of services that I'm starting to deploy in Amazon, and I want to configure who can access the cloud, and everyone should be doing direct egress to the cloud. So I could be configuring, for example, this compute policy class, a cloud attribute, capturing, for example, everything that is running in this Amazon EKS cluster has the cloud attribute. And then I can configure an access policy who can talk to cloud, who can talk to anything that has this cloud attribute, right? And we could say only the services in this egress namespace from the on-prem cluster can talk to cloud services. Anyone else will not be able to talk to cloud services. Or we can have other types of policies more tied to the physical world. For example, like network segmentation-based policies expressed with exact same APIs. So we could have a policy that is network segmentation, and we can start just creating attributes and grouping resources like DMZ. What is my DMZ? I could say my DMZ is anything that is in my perimeter network, for example. That could be the DMZ attribute. And then I can start creating access policies to configure who can talk to anything that is running in the DMZ. I could say anything in the DMZ cluster can talk to anything in the DMZ. And as well, I could say this ingress network can as well talk to services that are running in the DMZ, right? So this syntax is not limited to expressing clusters, stuff, right? You can express network, region, or even, for example, we could think about data access policy. We can think about a policy to protect access to a Kafka instance, for example. We could create a Kafka policy class. We could create a checkout topic attribute describing one concrete Kafka topic in the Kafka instance, and then configure an access policy saying who can publish messages to that topic, who can subscribe to that topic, right? And we could have an access policy, for example, saying only services from the Kafka app namespace can publish or subscribe to this particular Kafka topic, right? So these three APIs, like the policy class API, attribute assignment, and this access policy, with these resource references, give a lot of flexibility on how you can configure policies for many different use cases in a way that you can reason about, right? So we have seen cluster-based, network, for example, based resources, region-based resources as well, right? And the way it works is because you can imagine these resources being like mapping and targeting parts of the NGAC graph, right? So as we saw before in this representation of the Kubernetes cluster that we have here, where we have the cluster, namespaces, deployment, you can imagine these patterns that we are writing, for example, /clusters, /kind, which is the name of the cluster, /namespaces, all that stuff, targeting a path in the graph, right, to capture some nodes, like cluster namespace, capture that part of the graph. When you apply a policy there, that policy will cascade and be inherited with everything that's inside. Or, for example, when we target these regions / wherever, you can imagine targeting that other part of the graph, right? And that policy cascading down the hierarchy through the node, through the bots, to the service accounts that are really captured by that attribute. This allows you to not have to write these super fine-grained identity-based policies all the time. A new pod comes, you have a new identity that is part of this group. You need to update the policy, whitelist the identity, and so on. Still having identity-based enforcement, but you can have policies that allow you to scale better, to better reason about what's going on in there, because you can leverage this cascading semantics of NGAC to leverage all the policies, right? And it's just these three simple APIs, this syntax, and having the NGAC graph that allows you to do this enforcement, right? When we talk about data enforcement, or for example, you can imagine having your VPC in there that you can represent in the graph, then you can just have a policy that uses the VPC just because you can target that in the graph, right? And then it's just a matter of discovering things. It's just a discovery problem where you can discover your stuff, your infrastructure, your world, modeling in a graph. Then you have some APIs that you can target specific attributes and policies, so to have them cascade, and having the right policy enforcement points so you can intercept the requests at the right time and just cast the question to the PDP to evaluate these policies against the graph, right? In the case of service mesh, this demo policy enforcement point were the sidecars that were intercepting the requests and using the information in the graph and those cascaded policies to apply the access control. And with this, let me conclude. If there are any questions or so can you tie NGSC with routing decisions in the mesh? That's a good question. So NGSC is fundamentally an access control technology, so it's meant to just have Boolean yes or no access decisions when something happens, right? But the fact that you represent the state of the world in the graph gives you a lot of information to do all sorts of stuff, right? For example, inventory is like, give me all the services that this team has access to, or everything that is owned by that person. And you can use the information in the graph to build other features, like, for example, intelligent routing and things like that. But NGSC per se is purely an access control decision to make just Boolean access decisions, yes or no, although the graph can be used for way more. Right? So in the NGSC model implemented by NGSC, RCD's replacement to traditional STO authentication authorization policies or another layer, I would say it's another layer. So STO authorization policies can enforce what they know about, right? They know how to parse a JOT token, they know about SPIFFE identities, so they can do policy enforcement on those terms. With NGSC, you're elevating that a bit more, and you can write policies and do effective enforcement in other terms, in nouns, that you can create those attributes, do policy enforcement based on just the environment. So it adds on top. It's not a replacement, but it helps you have more meaningful access policies that scale better, that you don't have to maintain because they are not that much fine-grained, although they leverage the same identities and the same ideas. Since there isn't a prioritization of rules, it's a firewall, is the request denied if there are any denied responses from the policy? Yes. So in NGSC, we have different types of policies, and the semantics are based on so when you try to access a resource will have a collection of attributes, and the resource will be protected by a set of policies, right? So if the resource is captured by the environment policy class, location and data sensitivity, when accessing the resource, you need to satisfy all of them and have permissions in all of them, right? So while assigning attributes to resources and making them participating of a policy class, in order to access a resource, you need to satisfy all of them, right? There's no such a thing as ordering or something like that, or preference. It's just this resource is protected by this, and that. You need to satisfy these conditions if you want to access it. Yeah. Thank you very much.